At this time, you are going to Databricks Certified Associate Developer for Apache Spark 3.0 course. In this sectional module, we'll actually go to the details about partitioning data frames. Already we have seen details with respect to reading and writing. Now it is time for us to understand about partitioning. These are the lectures which will be covered as part of partitioning Spark data frames. First, we'll actually get an overview of partitioning data frames. Then we'll see how to partition data using single column. We'll also see how to partition data using multiple columns. Then we'll actually set up dataset for partition pruning, where we'll be using a bit larger dataset. We'll be partitioning the data and we'll be saving it into files. Once a dataset is ready, we'll also go to the details about reading data into Spark data frames using partition pruning, where we'll be reading data from partitioned dataset, leveraging the concept of partition pruning. It is very important for you to understand about partition pruning, and hence make sure you go to this lecture with care. That being said, partitioning is very important with respect to the projects, and hence make sure you are really comfortable with respect to partitioning. If you have any questions related to partitioning, feel free to raise those questions in the Q&A forum. As long as it is relevant to the course, I will make sure more content is added with respect to partitioning. As part of this lecture, let's get an overview of partitioning data frames. First, make sure you have a data frame. The reason why we need to have a data frame is to explore the APIs. It is better to create a data frame. Once we have data frame, then we should be able to review the details about partitioning the data frames by going to the APIs that are available. When it comes to data frame, in this case, which is nothing but df, there is an attribute called as write. When it comes to the type of the write, it is nothing but pyspark.sql.readWriter data frame writer. On top of this data frame writer object that is there on top of data frame, there is a function called as partition by. Using this function, we should be able to partition the data by passing a column or number of columns to it. You can see the data type of the argument here. It is nothing but varying arguments. When it comes to the type, it can be either string or list name of columns. When it comes to multiple columns, you just have to pass all the column names comma separated as different arguments. I'm not sure if you pass the list it will work or not. You can try passing the list. If it is not working, you can actually have a star before the list. It will take care of converting the list to varying arguments, and you should be able to invoke partition by without any issues. We also know that data frame writer exposes APIs such as JSON, Parquet, etc. so that data frame can be written into the specified file format in the target location. Some of the APIs might have keyword argument to pass the partition by. For example, in this case, if you look at df.write.parquet, it have keyword argument partition by. You should be able to specify the partition columns even using this. When you use this, you should not be saying df.write.partition by, then you should not be saying Parquet. You just have to say df.write.parquet, and you should be able to specify partition by, and you should be able to pass the partition by columns using a keyword argument. For APIs such as JSON, where there is no keyword argument, you have to specify partition by on top of data frame writer. Then you have to invoke JSON. You should be able to partition the data in that manner. With respect to Parquet, you have flexibility. Either you can specify partition by on top of data frame writer like this and then use Parquet like this, or you can directly say df.write.parquet. As part of arguments for Parquet, you should be able to specify partition by like this, and you should be able to specify the columns using which you want to partition the data. So when it comes to APIs such as Parquet, you have more flexibility compared to APIs such as JSON. You can also review other APIs that are available to write the data in specific file formats in the target location such as ORC, CSV, text, etc. and see whether they have the keyword argument partition by or not. It is highly unlikely that other functions than Parquet have keyword argument partition by. Parquet is becoming the standard, and hence Parquet gives a bit of flexibility with respect to partitioning the data frames in the form of keyword argument as well. That being said, this is a quick overview of partitioning data frames. Now let's go to the tasks so that we understand how to partition the data using one column first, then using multiple columns. Also, we'll go through some of the key concepts related to partition pruning as part of subsequent lectures in this sectional module. As part of this lecture, let's see how to partition Spark data frame by single column. First, you need to have a data frame. In this case, I have created data frame by name orders. It is based on the data in this location. This location contains JSON files. That's why we are using spark.read.json to read the data in this location into a data frame called as orders. You should be able to preview the data that is there as part of the data frame using show like this. You can see that the data frame contains 4 fields: order customer ID, order date, order ID, and order status. Let's review order date. The reason why we are reviewing order date is because we are going to partition the data using derived values from this order date. First, we will see how to partition the data by order date. Then we'll also see how to partition the data by order month. In both the cases, we need to make sure we understand the current date format, and then we need to come up with required logic to transform the data into appropriate date or month before partitioning. We will see those details as we go along. That being said, let's make sure we have an object by name username. It is primarily to have a dynamic location with respect to writing data to the target location. First, let's go to the details about partitioning data by date. We need to import data underscore format so that we can actually convert the existing order date with timestamp into whatever desired format we are looking for. In this case, we are going to transform order dates in this format: 4-digit year followed by 2-digit month and followed by 2-digit day of month. There are no hyphens in between. You can actually preview the data here. At this time, order date contain only the date part, that too in this format. Once we have order date in desired format, we should be able to use it to actually partition the data by that order date. Now, let's make sure that the target location is deleted. If you are using Databricks Platform, you should be able to use this piece of code to recursively delete the target folder into which we are trying to write. Then we are actually using the data frame with the order date in the desired format. We are using coalesce so that only one file will be used while writing the data into the target location. There will be one file per partition when we use coalesce. Then we are actually using write on top of it. Data frame writer exposes partition by. As part of partition by, we should be able to specify the columns. The columns are supposed to be valid columns that are there as part of the orders. You cannot pass an expression as part of partition by. You can only pass valid column names from the data frames. Once you specify partition by like this, you should be able to use Parquet and you can actually specify the target location. Now data will be processed and partitioned by order date. Then data will be returned to the target location in the form of Parquet. You can actually use dbutils.fs.ls on the target location to review the folders that are there as part of this. So this is the base folder. As part of this base folder, there are several subfolders. These are not files but folders. If you look at the naming convention with respect to these subfolders that are there as part of this base folder, you have order date, which is nothing but the column using which data is partitioned, then equal, then the date value you can see here. In this manner, you can find data for each and every date that is there as part of our original data. We have data related to 364 dates, and hence you'll be seeing 364 folders like this. Each and every folder will contain one file related to that date. You can also validate the count both on original data frame, which is nothing but orders, and also once you read the data from the target location, you can actually perform the count and validate. You can see even the target location contain 68,883 records. The original data also contain 68,883 records. You can also check the data types of all the fields that are there as part of the target location in the form of Parquet files. You should be able to first read the data in the target location using spark.read.parquet into data frame. Once the data frame is created, you should be able to use dtypes to actually review the data types. When it comes to order customer ID and order ID, they are of type begint. When it comes to order date, it is of type int. When it comes to order status, it is of type string. These data types are determined based on the data that is saved into the Parquet file format. There might not be one-to-one translation between the source data types and target data types. Also, you should be able to preview the data to see if the data is as per the expectations or not. You can see the data, it is as per the expectations. This is how we should be able to partition the data by date. Now let's go to the details related to partitioning data by month. In this case, we are actually having a derived column by name order month. It is based on order date using this pattern leveraging data underscore format function. So when it comes to order month, it is nothing but 4-digit year followed by 2-digit month. You can actually review the data here. When it comes to order month, you can see the month part of each and every date. Now we can ensure that the folder is deleted if it already exists. We are trying to delete this folder because we want to write into this location. In this case, the target location is nothing but /user/username read_db, then orders partitioned by month. Earlier it was orders partitioned by date. That being said, this is the logic which will take care of partitioning the data by month. We have used the similar syntax what we have seen earlier. You can actually review the details. Once you review the details, you can actually delete the folder, and then you can also understand how to pass partition by add the keyword argument to Parquet. You can see here, instead of using partition by on top of data frame writer, we are actually using keyword argument that is there as part of Parquet to partition by order month. Even this approach will work in the same manner what we have seen here. This approach and this approach will yield same results. You can now actually review the target location. The target location have 13 folders. You can see the 13 folders here. It starts with 2013-07, ends with 2014-07. In between there are 11, so total 13 folders. All the folder names are based on order month column, then equal to, then the actual month value. This is how the data will be preserved in files by having folders for each and every partition based on the order month. You can also validate by performing the counts on both the original orders data frame and also the new data frame which is created by using spark.read.parquet by passing the target location. You can see the count here. It contains 68,883 records. You can also read the data from the target location and you should be able to preview the data. You can also check the data types of each and every column that is there as part of the target location. In this case, as we have additional column before partitioning the data into the target location, you can see that the data frame based on this target location have 5 columns. The extra column is nothing but order underscore month. It is of type int because we have 6-digit year and month as part of order underscore month. This is how you should be able to partition Spark data frame by single column. Now let's go to the details about partitioning Spark data frame by multiple columns. As part of the previous lecture, we have gone through details related to partitioning Spark data frame by single column. In continuation to it, let's see how to partition Spark data frame by multiple columns. Most of the code is same as what we have seen earlier. The major difference is with respect to generating multiple columns based on which we wanted to partition the data and also specifying multiple columns. If you review the notebook, you can see that we are adding 3 fields to the original data frame, which is nothing but orders, which contain 4 fields: order ID, order date, order customer ID, and order status. The new fields that are being added are nothing but year, month, and day of month. The reason why we are adding these 3 fields is because we would like to partition the data by year, then month, and then by day of month. When it comes to year, it is nothing but 4-digit year. When it comes to month, it is nothing but 2-digit month. When it comes to day of month, it is nothing but 2-digit date. You can see the details here. Using this logic, we are able to generate these 3 additional fields on top of original 4 fields. Now, when it comes to partitioning the data, this is how we should be able to partition using multiple fields. On top of data frame, which have these additional fields, we should be able to use coalesce and then write. On top of data frame writer, we should be able to invoke partition by like this. As partition by can take multiple columns as arguments, so we should be able to pass multiple columns like this, and we should be able to write the data by partitioning using these 3 fields into this target location. You can see here. That being said, once you run it, you should be able to validate. You can see there are 2 main folders under the base folder. This is the base folder into which data is written. In that, the 2 main folders with respect to partitioning are nothing but year equal to 2013, then year equal to 2014. In that, we'll be having folders related to months, then we'll be having folders related to day of months. You can see here. So this folder is related to 2014 January 9th because year equal to 2014, month equal to 01, day of month equal to 09. You can actually review the output here. You can see that it contains a few files which are related to the dataset orders. The data is partitioned by year, month, and day of month. As we are trying to write the data in the form of Parquet, we should be able to specify partition by as a keyword argument, and we should be able to write as well. You can give a try. It should work. If it doesn't work, you can actually ping me. I will actually troubleshoot and help you about how to use partition by a keyword argument as part of Parquet instead of using partition by on top of data frame writer. This is how you should be able to partition Spark data frame by multiple columns. This is also known as composite partitioning. As we have understood how to partition the data while writing to the target location using single column as well as multiple columns, now it is time for us to understand the significance of partitioning from the read perspective. One of the key concepts with respect to reading partition data is nothing but partition pruning. To understand nuances related to partition pruning, it is better to have right dataset. As part of this lecture, let's go ahead and set up dataset for partition pruning. Then as part of the subsequent lecture, we'll actually see the advantage related to partition pruning. That being said, when it comes to Databricks, it actually provides quite a few public datasets in this location. one of the dataset that is available is nothing but airlines under ASA. As part of this location, we have 22 CSV files. We'll be using this data to partition by year and write to the target location. We'll be using that partitioned folder to actually understand the concept of partition pruning as part of the next lecture. That being said, the logic is similar to what we have seen earlier. We have generated an object by name username so that the target location is derived by user who is logged into the platform. Now you can actually take care of deleting the folder if it already exists. This code snippet will work as part of the Databricks platform. You need to make sure that the target folder is deleted so that we'll not be running into any unforeseen issues. Now this is how we should be able to partition the data by year and write to the target location. As part of this dataset, we have a column called as year. Using that year, we are actually trying to partition the data. When it comes to the target file format, it is nothing but CSV. The files will be written into this location. There will be subfolders based on year, and you will be seeing files in that location. You can validate by running this. You can see all the subfolders in this location. All of them have year equal to. It is because the data is partitioned by year. You can see that for each year there is a folder by saying year equal to that year number. As part of these folders, we'll actually see the CSV files because we have written the files into this location using write.csv. For that reason, these folders will contain CSV files. That being said, you can also try to read from the target location and perform the count. You can see the number of records we have as part of this target location. You can also review one of the year folder by saying year equal to 2004. In this case, we are actually reviewing the files related to year 2004. You can see there are quite a few CSV files in this. The number of CSV files are nothing but 1, 2, 3, 4, and 5. So it have created 5 CSV files in this location for that year. Once we run this notebook, we'll have enough size dataset as part of this location. We can explore partition pruning on top of this dataset. Let's go to the details related to partition pruning as part of the next lecture. As part of the previous lecture, we have gone through the details related to setting up the dataset to explore partition pruning. In this lecture, let's understand how to read data into Spark data frames using partition pruning. To leverage partition pruning, first the dataset is supposed to be partitioned. That's why we have taken care of setting up the dataset using partitioning as part of the previous lecture. We have partitioned the data based on year. That being said, this is the original location where we have CSV files. There are 22 CSV files. We are able to perform the count on this location using this piece of code. This piece of code will actually create the data frame. We can actually invoke count on top of the data frame to get the overall count for the data that is there as part of the files in this location. You can see that it have 123,534,969 records. This is the location where we have partitioned the data by year and populated the data using CSV file format. Even this one will create the data frame using that partitioned data. This one will actually get us the count. You can compare the count here. Both actually return the same count. When it comes to the execution time, when it comes to this piece of code, it took 1.91 minutes. When it comes to this piece of code, it took 1.98 minutes, which means the time of execution is almost same. Whether the data is partitioned or not, it doesn't matter because it has to go through entire dataset. Now, let's perform the count by using filter on top of the source data where data is not partitioned. In this case, this will actually create the data frame for the entire dataset. Based on that, we are actually filtering for year equal to 2004. Then we are trying to perform the count. Even though we are interested in data related to year 2004, it has to go through the complete dataset first to see what is the year in each and every record. If year is not 2004, then those records will be discarded in the new data frame that will be created because of this code. Now we are actually performing count on top of this. If you look at the count, it is only 7,129,270. When it comes to the time, it took 1.86 minutes. It is almost same as what we have seen with respect to overall count. There is no change with respect to the count, even though we are interested in only 1 year. When it comes to this location, we have partitioned the data based on year, which means there will be folders like this. There will be several folders under this location. Those folders will be like this. You will have column name equal to the corresponding value which is related to the partition. This folder will contain the data related to year 2004 only. Now, if you actually use year equal to 2004 like this, it will actually take care of only getting the data that is part of the files in this location. This data frame will only have data related to that folder. It will discard all the other folders. You can see the count matches. When it comes to the execution time, it is only 10.81 seconds. However, with respect to this code, there is no partition pruning involved. It is taking less time because we have hard-coded year equal to 2004 like this. You can actually expand this and review the details with respect to the jobs. You can see that this piece of code is executed using 3 jobs. Now you should be able to review this location. As data is partitioned by year, you can see a folder for each and every year. We have hard-coded for year equal to 2004. Whatever files that are there in this location are actually read and the rest of the files are discarded. That's why the performance is a lot better. When it comes to partition pruning, the partition pruning comes into picture when we specify the base folder like this as part of the logic which actually creates the main data frame. Then when you actually use filter on top of it, then it will actually trigger partition pruning internally. It is called as predicate pushing. Using the predicate here, it will actually determine what all folders it has to go through and what all folders it has to discard. This time, it actually uses partition pruning. You can actually see the count exactly matches. However, when it comes to the time, it is almost same as what we have seen earlier, where we have hard-coded the year equal to 2004. But when it comes to the number of jobs here, you can see that there are more jobs. There are more jobs because it has to apply this predicate push and make sure partition pruning is used to get the count for the data related to year equal to 2004. Partition pruning will also be used as part of Spark SQL. Let's see an example with respect to Spark SQL. To actually review the details with respect to partition pruning using Spark SQL, first we can actually create data frame like this using this piece of code by passing the base folder in which we have partitioned data in the form of multiple folders. We have created data frame. Airlines_df is nothing but data frame. Using data frames create or replace temp view function, we should be able to pass a name to the view and we should be able to register a temp view for this data frame. You can actually review the output of show tables to confirm whether the view is available as part of the session or not. You can see a temporary view by name airlines is available. Now you should be able to run SQL queries using spark.sql like this. If you look at the query, it says select count of star from airlines where year equal to 2004, which means we are only checking for year 2004. You can actually review the time. It only took 10.4 seconds, which means it have internally used partition pruning. You can also expand this and you should be able to see the details. In this case, it is only showing 2 jobs. It is because we are using Spark SQL, not the data frame APIs. With respect to Spark SQL, the plans will alter a little bit. That is why we are seeing only 2 jobs. Now let's review the details with respect to these jobs by going to the Spark UI. For that, we should be able to go to compute. Once you go to compute, you can actually click on the cluster using which you have ran those code snippets. Then you should be able to click on Spark UI. Once you are in the Spark UI, you should be able to review the details. However, we need to make sure we know the job IDs so that we can review. Let's go to the notebooks here. Let's click on this. Let's scroll down. Let's start with this one where partition pruning is used for the first time. You should be able to expand this. You can see that it have 5 jobs. 38, 39, 40, 41, 42. Before that, we have ran without partition pruning. It is nothing but this one. Let's expand. We have job IDs 35, 36, 37. So 35 to 37, then 38 to 42. Those are the jobs which we can review to compare the details. Rest of the things will be same as what we see here. Now we should be able to go to compute, then Databricks cluster, then Spark UI. Let's go to 36, 37. These are the ones which we are interested in. You should be able to review the time. With respect to this one, it is only taking 35 milliseconds. This is 10 seconds. These are the ones which we are interested in. I guess 36 and 37 are the ones which we are interested in with respect to the first attempt. We can actually click on this. We should be able to go to SQL. Let's scroll down. These are job IDs and hence we should be able to go to this. Then we should be able to review the details. You can actually expand this and you should be able to review the details. You can see that it is hard coded. That is why it have only read files from that location. However, if you review the explain plan for the next set of jobs, let me go to jobs once again. Now let's scroll towards right. We have reviewed details related to job 36. Now let's pick the one which actually took 11 seconds. The job associated with it is nothing but 41. We should be able to click on this. We can click on SQL. Actually, we can directly get onto SQL and then we should be able to click on the appropriate job ID. This is not the one which we are interested in. I think these IDs are different. Let me go here. Let me go to the jobs. Let me go towards right. In this case, we are interested in this. Let me click on this. It is nothing but job 41. I would like to see the SQL for this. I need to figure out how to get the SQL. Let me click on SQL here. These IDs are different. We should not be reviewing these things. Yeah, you can actually see here. So this is the details with respect to job IDs 41 and 42. So whatever job IDs we are seeing as part of jobs page are visible here. You can see the time also to confirm. Now you should be able to click on this, and then you should be able to scroll down, click on details. Then you should be able to review the details. In this case, you can see that it is actually using partition filters, which means it is actually using partition pruning. This is how you should be able to read the data from partitioned datasets using partition pruning. It will definitely improve performance in most common scenarios. Partitioning is one of the widely used performance tuning strategy with respect to getting the results as fast as we can from the data lakes. That being said, make sure you are really comfortable with respect to partitioning. You can expect 1 or 2 questions around partitioning. It is very, very important for you to understand how partitioning is typically done. There might be scenarios with respect to partition by, or there might be some theoretical questions about performance improvements related to partitioning. You need to be familiar about both the details. That being said, we can also partition the tables using single column or multiple columns. Partitioning using multiple columns is also known as composite sorting.